All right, let's look at 2.5, problem number 47. All right, this is an example of the method of variation of parameters. All right, so we have this variation of parameter formula. Let's use that to find the particular solution. All right, let's do that. All right, so first we need to do a characteristic equation, find the complementary solutions. So let's see, characteristic equation would be y double prime, so r squared, 3y prime corresponds to 3r, and 2y corresponds to just 2. All right, so we can factor this out. It's going to be quantity r plus 2 and times quantity r plus 1 equals 0. All right, so which means that r is going to be, we're going to get the two distinct roots, -2 and a -1. All right, so which means that we're going to get a couple solutions, complementary solutions. So y1 is going to be e to the -2x, and then y2 would be the other guy, so it's e to the -x. All right, so let's find the Wronskian, since we need Wronskians here. So Wronskian of y1 and y2 is going to be, all right, so y1 is e to the -2x and y2 is e to the -x. Then derivative of that would be -2 e to the -2x, and derivative of that is negative e to the -x. Right? Right, then take the determinant, so it's going to be this guy times that is a negative e to the -2x -x, so -3x, minus, right, this times that is negative, so double negative, plus 2 e to the -x -2x -3x. Right, so that's going to give us e to the -3x. Right, that's our Wronskian. Right, so let's see, so you have two terms, so let's compute them separately. I'm gonna call this guy, right, integral 1, and I call this guy integral 2, and I try to do it separately. So we have I1 is going to be, right, it's negative, right, y1 is e to the -2x, integral, y2 is e to the -x, and f of x is the right hand side, so it's 4 e to the x, and we just found out that Wronskian is e to the -3x, right, dx. Right, so this is going to be equal to negative e to the -2x. All right, so let's see, we can cancel those guys. All right, then this is dividing by e to the -3x is same thing as multiply by, so maybe I'll write it down here. So this is equivalent to integral of 4 e to the +3x dx. Right, so this is going to be equal to negative e to the -2x. Right, antiderivative of that would be, let's see, 4 is there. Antiderivative is e to the 3x over 3. Right, so which is going to be, so it's a -4/3 Right, so e to the negative 2x times e to the 3x is e to the x. Right, how about I2? So let's compute that. I2 is going to be, y2 is e to the negative x integral. I1 is e to the negative 2x times right hand side is 4 e to the x divided by e to the negative 3x dx. Right? So this is going to be e to the negative x times integral. Right? So we're going to have to multiply by, let's see, e to the 3x. So that's e to the 2x. So e to the 2x here, and we have 4 dx. Right? Then take the antiderivative of that. So e to the negative x, and 4 antiderivative is e to the 2x over 2. Right? Then we can cancel 2 and 4. So there's going to be 2 left over. So we end up getting 2 e to the x. Right? So what we're looking for is y sub p. So y sub p is equal to I1 and I2, which is negative 4/3 e to the x, plus I2 is 2 e to the x, which is going to be 2 is the same thing as 6/3, so it's going to be 2/3 e to the x. Right? So this is the y sub particular solution we can get from this method of variation of parameters. Right? That's it. I hope that this was clear.